Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In today's episode, we're going to be taking a look at ranges in the standard library. So without further ado, let's just go ahead and dive in. So I'm going to go ahead and take you here to dlang.org, and we'll go ahead and look at the library reference, and where we're going to be heading is ranges. Now, ranges are really a tool that work together with algorithms, so we kind of have to talk about them together. But before we dive in here, I'm going to go ahead and give you a little bit of intuition as to what a range is. And I think you already kind of know from the name here, but it's worth it to just kind of slowly build up here. And we're going to talk a little bit about ranges in the up and coming episodes as well, so make sure you stay tuned for those. But let's just start with something simple. So we're going to basically create a little, what we often call dynamic array. That's just a pointer and a length, as we'll find out in the details here. But let's just create some values here. Let's just put in some odd numbers in data. And let's just go ahead and iterate through data 1 here. So maybe IDX for the index, or just I for short. We'll start from 0. And while we're less than the length of whatever data 1 is, then we'll go ahead and go through and just write out all of these elements here. So something simple like that here. Let's just make sure we're on the same page and everything's working. So great here. Okay, so what have we done here? Let's just kind of illustrate this. So I have data 1 here. And let's just go ahead and kind of get a visual here of these 5 elements here. So always useful to draw here, 1, 3, 5, 7, and 9. And again, what have I done here? Well, I've defined a starting point here that's at index 0. So I could just go ahead and write it out here. Let's write out the indices 0, 1, 2, 3, and 4. And I have my endpoint here, which ends up being the end of this array here. Now, more generally, this is just the start, and this is the end here of my iteration, or the sequence that I'm evaluating for this data 1 here. Now, assuming that end and start are legally defined, which, well, I put 0 here, and we're going to trust my conditional statement here to make sure that I don't go over the length here, we're in good shape here, right? Now, of course, I can come in here and mess things up here, right? Now, let me go ahead and just do something like this here. Let's go ahead and run this code. It doesn't crash. Nothing crazy happens. That's good. So, if I screw up the beginning here, not too much of an issue because my condition is going to catch it here. Okay, so let's go ahead and reset that here. But what if I have something like this? Well, I is less than, 20 here. Let's go ahead and run that. Well, yeah, D is going to throw us an exception here. And one of the safety features of D is bounds checking, which of course you can turn off if you're pretty sure that it's not working or after you've tested enough. But again, we've messed this up. So we've gone outside of our boundary here of this data here. Now, of course, one of the tools that we have to fix this, so, assuming that maybe I'm a little bit not careful here, or otherwise just want to show the intent of iterating through the whole collection, is a for each loop here. So we could do the element here and data 1, and then I can write out each of the elements. Let's go ahead and just do this just to show that we get the same thing on both sides. So, 1, 3, 5, 7, 9, and 1, 3, 5, 7, and 9. So no problem here. And this shows the intent that, well, we want to go from the start to the end here, okay? So in a way, for each is sort of this defining thing, this range, as I'll go ahead and define it, that says I want to go from this point to that point, okay? So for each will be an example of a range. But let's just sort of define range. And, maybe there's a more formal definition here, but I'm just going to say here the defined start, okay, and we'll underline that, and end of a sequence, okay? Now, again, our sequence here is this dynamic array type of thing here. Again, whenever I see this in D, that means pointer plus length, so we want to be a little bit precise about that because that's really what it is. It's not really a container, but, again, we usually call this dynamic array because that's kind of how it acts here. But anyways, that's the idea here, with our range, start and the end of a sequence here. And for each, I'll just go ahead and put here, for each is an example of a range that says, go from start, that says go from, let's just go ahead and write this out, start to finish. Okay, so you already know a little bit about ranges here if you've watched this series and you know about for each or otherwise have seen how this works here. Now, I want to show you a little bit of the magic here behind ranges. So if we go ahead and click on ranges and open up the tab here, we've got a definition here. So basically, what a range is, and actually the best maybe introduction is on the D language tour here. But basically, ranges generalize this concept for arrays, lists, or anything that involves sequential access about how we, well, access a selection or a chunk of data. Okay, so again, it's just a start and an end. Okay, that's all a range really is. So we don't have to, again, overcomplicate things. But it is worth taking a look at the D language tour here and seeing that thing that we're familiar with, the for each loop here, is internally rewritten to something else. So there is something, right, intelligent happening that says, hey, tell us where the start of the range is and keep going until the end. Okay, so we're going to see these things come up here. And when we talk about iterators and writing our own iterators for our data types here, you're going to see these things like empty or pop front here. And if I zoom in and we kind of stare at it for a little bit, and if I tell you this just gets written internally as a for loop, so for each is really just syntactic sugar that gets lowered down to this, so hopefully this makes a little bit of sense here. I know what data I'm looking at here. So I get a copy of my range here, in this particular case, if I'm not using a ref or anything. And while my range is an empty, meaning this copy of, well, the stuff that I'm looking at here, I want to just keep popping elements. Yeah, popping an element until I get to the end, right? That is my end condition when I'm empty, and that's the basic idea. And the element that I'm looking at is, well, whatever happens to be in the front here. So again, just to sort of visualize this, if I use a for each loop, right, my range is going to be the whole thing here. And I basically just keep looking or popping off the front element, and then I get rid of it. And then here's my new front element. I get rid of it and keep popping and popping and popping until I'm empty. Now, what makes that kind of interesting is, what if my range is infinite? Okay, and that's something that ranges enable, which is really, really neat. Or if I'm slowly adding to something. Or what if I only really truly need to evaluate a few of the first elements here? I don't need to evaluate everything, but maybe this is an object in here. It's not just an integer, but something more expensive. Well, then I only have to pay the price of popping off the element in that range and then evaluating it. So that's what we would call sort of a lazy evaluation. So ranges allow these different types of operations by this abstraction here of telling us, well, I've got a range that gives me a start and an end. So hopefully it's becoming a little bit apparent that there's at least something interesting with this idea of ranges, something important enough that we have a, well, module here in the D standard library for ranges. So again, just remember at the very least in our example here that with for each here, I'm not going to mess up these indices, right? I don't have to remember the length or all these different things here. So that's one of the nice things here. Now, ranges also, again, allow us to do interesting things here as I scroll down here with how I, well, do that selection. Now, again, in our illustration here, we just sort of selected the beginning and the front, but again, I could have selected the, or changed the index here to be the first element or the second element or the third element, and that would, of course, compress my range that I'm looking at. But you might wonder, why am I doing that? Or maybe I should do that based off of something more defined. So that's why we have, again, a bunch of these options here to choose from. Okay, so let's just go ahead and play around with a few of these range ideas. And then I'm also going to go back here and open up algorithm here, just so we can kind of play with both of these, because we want to start introducing these in our code here. So anyways, let's play around with some ranges here. And let's take a look at chain here. So it concatenates several ranges into a single range. Okay, well, okay, I need several ranges. Let's go ahead and do data 2. And again, just to make things, interesting, let's go ahead and make these even numbers here. And what exactly is this doing here? Well, let's go ahead and comment out this guy here. And I'll go ahead and say, okay, data 1, or rather, let's look at chain here. And what is chain here? Okay, it takes a series of ranges, or at least something that can be converted into a range like one of these guys here. And what if I did chain, and whenever I see ... that means I can do any number of parameters here. So I can have any number of ranges, RS's, ranges, like that, data 1 and data 2 here, okay? Well, let's go ahead and try to run this. And well, look at that here. Now I've selected from 2 separate containers here, and I've iterated through, well, all of them here. Now, of course, if you want to do something interesting, like interleaving them and so on, we can maybe think about how to do that here. But that's the basic idea with, well, something neat here, chain, okay? And then what about choose here? Okay, let's take a look at this one here, choose. Okay, based off of a Boolean condition here. So let's take a look at choose. Okay, so choose range. Let's go ahead and try. Oh, let's look at the function signature here. So here's the condition, and do I want to use the first range or the second range here? Okay, so let's just go ahead and change this to choose. Okay, because maybe in a game you want to use the first data set if the level of difficulty is difficult, and choose a second data set if it's like less difficult or something, right? You can imagine this case here. So let's just put in a Boolean here like true and try this out, and you see I get the first set here. And if I do false, I get the second set. And that's pretty nice because, imagine I need to rewrite this here without choose. What does this look like here? Okay, so it looks like, let's just go ahead and copy this. If I don't have this algorithm, I have, well, some condition here. I have if true, do something, else, do something else here. And I have to take my original loop here, and I have to paste this guy in here, and paste this one in here. I mean, you're going to get the point here. You're probably already tired. You're thinking about clicking off on the video, but you're not, of course. But, you get the point here. I've introduced this Boolean condition. I've copied my loops here, going through data 1. Maybe I've forgotten to change this to data 2. Maybe I've messed up the indices. Immediately, again, we have these nice tools that tell us how we select data. That's, again, the point of all of these range algorithms here, okay? So let's go ahead and take a look at some more here. You can create cycles, drop and take, which are interesting. Here, let's get rid of this here. And, of course, I can start combining these. So let's just look at one quick example here. Let's do data 1, drop 1. Let's see what that does here. Okay, so drop creates a range that results from discarding the first n elements from the given range. Okay, so if I'm going to drop the first element here, that's like 1 here. So that's like, in the terminal, if you've used commands like head and tail, this is going to be familiar here. Now I got to get my parentheses right. You can do something like that. So again, I get rid of the first, 2 elements here this time. And you can see we're, again, changing our range here. Okay, and again, that's pretty clear in the code what's going on versus using some index here. So again, these could be really nice here. And maybe, again, you want to do something like drop that, and then I want to chain together with data 2. So let's use something like that here. And that gives me the first few elements here, and then all of data 2. Okay, so again, you can see very nicely how ranges compose, okay, using the things that we're used to in D here. Okay, so let's take a look here at a few other neat things here. And I'm just kind of looking through here. Even chunks, that's kind of an interesting one. Let's see what this is here. Okay, so maybe I've got a collection of data here, 1, 3, 5, and 7. And let's just go ahead and let's take data 1 here. And let's go ahead and do data 1. We do even chunks here. And how even do I want them to be? Maybe in 2s. Okay, let's go ahead and try that here. Okay, so it tried its best to kind of split this up into 2s. I mean, I guess we've got an odd number here. But let's go ahead and, well, let's add a little bit more data here. Let's see if we did get it into even chunks here. Okay, now we get even here, right? So, of course, if we have an odd number of elements, that's not going to make sense here. But that's kind of cool. I was able to break this up at the midpoint. So that's almost like a partition, if you will. And then I could keep, partitioning this. So again, these are very fun to play around with and to see what's available here. Here's another handy one, generate. Let's go ahead and try that because that's going to combine a few interesting things here. So let's go ahead and say we want a for each loop here. But maybe I don't have a collection here because I want to generate this data dynamically. So I'm going to use a template here. And let's use the example that they have here. I times equals 2. And we are going to need to add a little bit more here. So this isn't going to take any parameters here. So let's go ahead and close that off here. And let's do take 2. Okay, this is going to be a new one here. Let's go ahead and try to run this here. Let's see here. I gotta make int I equals, let's make it 1 here. And follow the example. And I get 2 and 4 here. So generate, I know a lot of folks might be familiar with this with generators. This is often a concept that folks like using with coroutines, for instance, but I have generate here. And I could just create a range here using this lambda function here to just, well, follow this pattern. I times equals 2. And I need to hold the state somewhere here. That's why I've got it set up here. And then take just tells me, well, how many times do I want to keep taking elements from this range? Let's go ahead and do 3. Let's go ahead and do, 9. And I could do something like that here. Now, can anyone think of something that's kind of similar to generate that you might have used or might have shown before? Let's go ahead and try this one here. See if I can do it from memory, but iota. So 0 to 10 and a 1 step. And let's go ahead and just write out those elements. Something like this. Let's go ahead and comment out this guy just so you don't get confused. And there you go, iota. So that's another one of our range functions just below here that we can see. So hopefully you can see how some of these range functions could be useful. There's all sorts of interesting other things here, like if you want to reverse a range, if you want to repeat the range multiple times. I mean, let's look at a common example where you might want to do something like this. Let's just say right line, something like this here. Let's go ahead and give this a try here, like a dash. And then you could just create your range like so. I don't know. Let me see if I found join. That's part of another thing here. But, if you ever want to create like a bunch of characters at once or something, you could start with repeat and then join them together. So again, you have a bunch of different ways to traverse your data here. And there's other ones like zip, for instance, that you'll see in languages like Python. Let's go ahead and try this because this often comes in handy if you're processing some data. So let's go ahead and just work with our 2 ranges here. I'm going to comment out the rest here just so you can see what we're working with. And for instance, let's go ahead and let's do for each element, or really it's going to be a tuple, I guess. It'll be a collection of them. Let's zip together data 1 and data 2. And let's just write out just so you can see the tuple here. And you've got a pair of ints, and you can see 1, 2, 3, 4. So it's just matching the first elements here. 1, 2, 3, and 4 becomes a tuple, and so on and so on. So if you've worked with comma separated values or tab data or stuff that you're extracting with from spreadsheets, this is where I most often use some of these things like zip, for instance, for building tuples of all the columns and rows. Okay, so this is touching on and playing with a bunch of the different functions that we have available in the range library. But let's take a look at some other things that might come up in your code here. So let's go ahead and comment this out. And let's say we have another data set here. Let's say we have something like a set of 4 integers here, like data 3, something like this here, okay? And let's say we want to do the same thing like we were doing. Let's do for each element in data 3. Let's just take the first 2 and let's try to write them out. Okay, so I get the elements here from data 3. What happened here? Well, let's see. It looks like I'm getting some error messages. It says no property take for data 3 of type int 4. Well, I mean, this looks like something that we've had before. There's 4 elements here. The following error occurred while looking for a uniform function call syntax match. Template take is not callable using argument types, etc., etc. And then it's giving us, some of these cryptic things. But the important thing is this template constraint that's saying is an input range here. Okay, that's the thing that's not being, satisfied. So the question is, this isn't an input range, so I can't do anything with it. But how could I make this an input range? I mean, I could assign one of these, things here. Like I could say like slice equals data 3 maybe. and then do maybe something like this. And that works because, right, we discover that this is a range. It is something where I can sort of pop off elements or look at them, okay? That's a little bit of a hack there. We have, and I might need to import one more library here. Another thing that you could do is just do dot array here, okay, which kind of converts it into, well, basically what I just showed you, that it converts things into a sort of input range type of thing here. Let's see if that was actually in, I don't think that was actually in here anywhere. But that's another trick. So if you ever see me doing that, frequently, or if I have a static array, then you can use all of your ranges library here. Okay, now I'm going to go ahead and stop this in a moment here, but I did say one of the advantages with ranges is that we can then use them with algorithms. So let's just go ahead and do like a quick little example here where I might want to navigate with some data here. Let's go ahead and comment these out here. And let's say I have a bunch of data sets. So here's the example. Maybe I'm downloading all of these data sets into separate arrays in parallel, and then I want to search them. Okay. So let's say for each element here, and I'm going to chain together. Let's chain together data 1 and data 2. Okay, just like we did earlier. We saw that example. Okay. And let's just go ahead and write out the elements, make sure it's working. Okay, so we've got all of our elements here. And then what I want to do is, while creating this, selection of data here, I want to filter them. Okay, so let's use filter. We could look and remind ourselves of the filter syntax, taking in some lambda function here. And let's go ahead and say we want something like a equals, let's do something like a mod 2 equals 0. Something kind of classic like that here. Okay, let's try to give this a run here. Oops, and I get a little error here. We need to add in the algorithm library here. Okay, now I just got my odds here. And let's make that a little bit more interesting. Let's say, I don't know, for whatever reason, A's got to be equal to an even number, or A is greater than 5. Okay, so something like that here. Okay, so we have a few odds here. We're just filtering some data that we have chained together here. So we're changing our sequence of things here. And then what I want to do here is just take the next 4 elements, or the first 4 that I find here. Okay, oops, let me run this. There we go. And I just get the 4 elements here. So let me make this a little bit larger here. And typically what we do here, just so we make it a little bit readable, is, some people have different styles for this, but here, let me actually put it something like this. A lot of folks like to do here. There we go. But anyways, you can see how with ranges, we're able to, again, select our range, whether it's from a sort of a pointer and a length, or a fixed size array, which we can use with dot array. We can then start composing with our algorithms to filter, and then also, well, take whatever we filtered out there using that algorithm and build another range from it, of just these 4 elements. And we could copy these somewhere if we wanted to do all sorts of other interesting things. But anyways, that's sort of the idea, or a little introduction and playing with ranges. And it might be interesting for you to do, just as an exercise to sort of practice with these, is to go through a code base that you have, or some decode, or even some of the previous videos if you've been following along with those lessons, and just replace all of your raw loops with these ranges, or basically for each loops, and see if you're able to do that. See if you're able to write better code that might be more understandable, or maybe more composable, and sometimes that can be more performant by using ranges. Okay, so it can be a fun thing to try, just as sort of like a mental exercise to see like how short you can make your code. But it often can be just the right thing to write more maintainable code, and code that, again, in some cases is more performant, or maybe is amenable to things like dot parallel and these, sort of other interesting tools available. Now, what this also alludes to, I just want to go ahead and point out a famous talk by Sean Parent. You can see the URL, or if you search C++ seasonings by Sean Parent, this goes back to the old, mantra here of no raw loops here. And I think this is something that I wanted to point out, even though this is a D series. Of course, I do C++ stuff as well. But a really powerful ranges library allows you to, in combination with algorithms, which are sort of the glue that puts things together, with containers, which we're going to talk about in the next video, just write, again, really composable and potentially, or I should say in many cases, less error-free code, and many times code that has potential to be more performant, because maybe it becomes more evident that you could do something in parallel or just stick on a dot parallel on that code. So anyways, it's worth a little exercise here to try to get your code to reach this goal of no raw loops. I'd encourage you to watch Sean Parent's talk if you haven't. And otherwise, the other exercise to do here, I know we didn't do anything like super concrete, but it is just to go through the standard range and look at some of these algorithms, see if you find something new and try it out. And with that said, folks, we'll go ahead and end the video here with that introduction to ranges. And then we're also going to be talking about iterators to kind of put this together here and make everything otherwise very cohesive with what we followed with today. All right, folks. So with that said, as always, feel free to check out these resources like Sean Parent's talk. Otherwise, as always, I have the videos for the deprogramming language website on courses.msha.io. We also have the forum at forum.msha.io that we're trying out here, so feel free to engage in that. Go ahead and post some interesting snippets of range code, or whatever you came up with, maybe your favorite algorithm, maybe something that you think is missing in the standard library would be also interesting to share. And otherwise, I'd be curious to hear your thoughts about different ways that you've been using ranges, when you discover them, if, again, they have been very useful for you. I think they're really useful and well done in the deprogramming language, especially with the uniform function call syntax. It makes it really easy to compose code. So I really like to use them and find different use cases where I can just tighten up my code and make my code more error-free, and in many cases more performant. So anyways, with that said, folks, I'll go ahead and end it here. Thanks for your time and attention, and I'll look forward to seeing you in the next one.